Hey, welcome everybody. So let us continue our lecture. We are talking about discrete versus continuous variables. Remember last time we talked about different types of events? Recall? Last time we introduced different types of events. And we said that, hey, we can calculate the probability of those events. The probability of an event is equal to, well, the cardinality or the size of that event divided by the cardinality or size of the sample space. So the size or the cardinality of that event divided by the size or cardinality of the sample space. Okay, perfect. Then we also said that, hey, we have some variables that we are interested in finding their probabilities. So first, we're going to divide up a random variable into two types, two classifications. Then we're going to talk about their probabilities in chapter 4 and in chapter 5. So it was chapter 3 that we talked about the probability of an event. In chapter 4, we're going to introduce the discrete probability, discrete variable, then discrete probability. Then in chapter 5, we're going to introduce the continuous variable, continuous probability. What's the difference between these two? Let me start by giving you one example. What is the difference between the following variables? The very first variable that I'm going to give you is the number of students sitting in this class. Okay. The number of students in this class. And B, the volume of a water bottle. Okay. Very well. So first of all, I'm talking about a variable. What is a variable? Remember that. In algebra, we learned about a variable. A variable represents some numerical values, but those numbers are changing. A variable represents some numbers. Like in algebra, we had different types of variables on the right. We had x, we had t, we had y. X, t, y. These are different types of variables that we had. These variables can take on different values. based on the question, based on the example that you're dealing with. So here, I'm saying that, hey, I have a variable. What is that variable? The number of students, okay? So can I count the number of students in this class? 1 student sitting in this class, 2 students sitting in this class, 3 students sitting in this class, and so on. That variable, the number of, the keyword, the number of. This is your keyword. Keyword, the number of students, the number of books in my library, the number of chairs in this room. These are all examples of countable or discrete variables. So the answer that you're going to write is, this is an example of discrete or countable variable. A countable variable. Okay, that makes sense. I can count it. 1 student, 2 students, 3 students, and so on. Well, here I have the volume of a water bottle. The volume, okay. The area of this room, another example that fits into this category of this room floor. Another example, the height of students in this class. Okay. The types of questions like this. You should be asking, are these discrete or countable? Can I count the volume? Can I count the area? Can I count the height of students? These are all examples of continuous random variable. So you're going to say, hey, these variables are continuous variable. So what's the difference between that? The main important thing is that for a discrete random variable, you are allowed to count, and for continuous random variable, you cannot count, but you can fit the numbers in between 2 numbers in an interval. A discrete random variable is a countable variable. That's it. You can count it. A continuous random variable can take on any numbers between 2 other numbers. Or in algebra, we say that, hey, we have an interval. So if you want to represent this, you're going to write it as an interval. The first number, the second number, and all numbers in between. Of course, you can include the middle numbers as well. We cannot count them because they take on all the values in between. You usually have decimals involved in a continuous random variable with decimals. For a discrete random variable, those are mainly numbers, numerical values that are countable. So suppose you have the following examples. I asked you which one is discrete, which one is continuous. So is discrete, which one is continuous? The first one was the number of, guys, the keyword is given to you, the number of M&M candies in a jar. Well, we're going to say that, hey, I have the keyword, the number of. The number of is the keyword for discrete. Discrete or countable variable. The second one is the volume of water, the volume of gas, the volume of gas in a 21-gallon tank. So think about it this way. Suppose I have, for example, a bottle of water here. This is the bottle of water, all right? So how do you count it? Can I count each drop? How many drops are here? So it's going to be a continuous random variable. It's the volume. You cannot count each drop. But if you think about the M&M candies, M&M candies, I can open the door, open the lid, and then start counting how many of these candies I have here. Discrete, countable, uncountable, because we cannot count the number of drops. The volume, the area, these are all examples of continuous random variable. What is this? The volume, the area, these are examples of continuous random variables. Let's take a look at the following example. Well, you're the statistician, and this is the project, this is the research paper that you saw. Constructing and graphing a discrete probability distribution. An industrial psychologist administered a personality inventory test for passive-aggressive traits for 150 employees in a company. Each individual was given a score from 1 to 5, where 1 is extremely passive and 5 is extremely aggressive. A score of 3 indicated neither trait. The results are shown at the left-hand side. Question says, hey, construct a probability distribution for the random variable x, then graph the distribution using a histogram. Well, okay. So first of all, we are dealing with a discrete random variable. The score is a random variable. The score is changing. The score can be 1, the score can be 2, the score can be 3, the score can be 4, and the score can be 5. So our random variable is x. Okay, so what about the frequency? The frequency or the count is the number of people who got score 1. 24 people scored 1. 1 was extremely passive. So 24 people got score 1, it means that they are extremely passive. 33 people got score 2. 42 people got the score 3. 30 people got the score 4, and 21 of them got the score 5. So this is our project. Our goal is to know what is the distribution like. Remember in statistics, we start by asking a question, we collect the data. Next step is to visualize the data and eventually associate some numerical values to the collection that we have. Let's go to the board and start constructing the frequency distribution. So this is our goal. We talked about discrete and continuous random variable. Now our job as a statistician is to visualize their probability distribution instead of just using the frequency table. Take a look at this. So now that we introduced a random variable, we are interested in visualizing and analyzing the data using their probability distribution. Well, when you're talking about their probability distribution, you're talking mainly about the relative frequency. So when I ask you to construct the probability distribution, I'm asking you to use the relative frequency. Relative frequency. Okay, let's go back to our example. In this example, we have the following. I have my x values. Let me move this table a little bit to the side because I need to write down all of the data. My x values, which is my random variable. I have the frequency or the count, f, or the count. Remember that in constructing our frequency table, we started by having classes, but instead of having classes, we're going to use just x as a random variable. The very first x is 1 with frequency 24. Now, in the next step, we're going to calculate the probability or the relative frequency. Okay, how do I do that? This is equal to P of x or just or relative frequency. Relative frequency. Okay, it's easier to remember how to calculate the probability of a discrete random variable. Remember that we are focusing on the discrete random variable. X is discrete random variable. Okay, very good. So how do we do that? What was the definition of relative frequency? It was the frequency of each class divided by the total number of values in your collection. All right, okay. Not that hard. X is 1, then my next x is 2, then my next x is 3, and then I have a 4 and I have a 5. All right. These are again like your classes, but instead of class, you have random variable. Remember that what you need is the frequency. How many data do I have? The frequency of the first class of the first score is 24. The frequency of the second class, the second score is 33. The frequency of the third class, the third score is 42. The frequency of the fourth class or variable x equals to 4 is equal to 30. And finally, you have 21. So if I add all of these together, what is the sum? Okay, after finding the sum, you're going to just easily construct the probability for each of these classes, for each of these variables. You're going to say, hey, the probability of 1, the probability of score 1, the probability of first class is equal to 24. The count of that class divided by the total. The probability of the second class, the probability of x b equals to 2 is the frequency, the count of that class, the count of that exact variable divided by the total. The probability of the third class, x equals to 3, is the frequency of that class, the frequency of that score divided by the total. The probability of the fourth class, or the probability that x equals to 4 is equal to its frequency, the count, divided by the total. And finally, the probability of the fifth class, or x be exactly 5, the score being 5, is the count, which is 21, divided by the total. So what is the total? The sum is what? The sum, the count, very good. The sum or the count, all of the employees who participated in this survey, the total number of them is 150. Very good. So the sum is 150, right? This is the sum, 150. You're going to write this 150 on each of these denominators and calculate the same process that you did before for relative frequency. Calculate the relative frequency. Okay, the very first one is 16%. The second one is 22%. Thank you so much. The third one is very good, 28%. Am I right? Perfect. Thank you. 28%. The fourth one is 20%. Thank you. And the last one is 14%. So, what's the meaning of that? It means that, hey, 16% of all employees who participated in this survey have score 1. 22% of total employees who participated in this survey got score 2, and so on. So how do we visualize that? Now, let us graph this histogram. Okay, so remember that for a histogram, we start by having a horizontal line. We're going to have classes, but in this case, instead of having classes, you're going to have your x values. On the vertical line, you're going to have your relative frequency, or in this case, just the probability of each x. So P of x. Remember that. When you're constructing your histogram, we cannot have any gaps between parts. They must be attached together. So the scale, the maximum is 28%. So let us have the 30% as the maximum scale, and then we have 15%. And here you have 1, x equals to 1. Then you have x equals to 2. Then x equals to 3. X equals to 4, or just 1, 2, 3, 4, 5. It doesn't matter. Writing x equals to 1, 2, 3, 4, and 5. Now let us start. When x is equal to 1, its probability is 16%. 16%, okay. I'm going to have a bar stops at 16%. Okay, not that bad. It wasn't very challenging. When x is equal to 2, the probability of x equal to 2 is 22%. Okay, let's just move a little bit up. 22%, hopefully it's here. 22%. When x is equal to 3, its probability is 28%. Okay, let's just move up. 28%. When x is equal to 4, its probability is 20%. Okay, just roughly here. 20%. And finally, when x is equal to 5, its probability is just 14%. So it's going to be roughly here. The last bar. This is our probability distribution. This is our probability distribution for x. For x. Since we are using p of x as the vertical number, vertical line values, you're going to have a probability distribution for x. Well, now I expect you to ask, we visualize the data, okay? This is the graph. We ask a question, we collect the information, we visualize them. Okay, now what's the next step? What's the mean? What's the standard deviation? What is the average score for these people? What is the variability of this score for these people? How do I calculate those? Okay, perfect. First of all, we're going to represent some formulas for you and give you the background of what's going on here. So, to calculate the mean, what are you going to do? You're going to take each x value, multiply by each p of x, then add them all together to find the mean. Take each x value and multiply that by its p of x. So what do I mean by that? 1 times p of 1. So 1 times p of 1. 1 times p of 1. 2 times p of 2. 3 times p of 3. 4 times p of 4. And 5 times p of 5. Okay? Then add them all. So after you do the multiplication, you're going to add all of these numbers together. This guy is going to be your mean. Mu is 1 times p of 1 plus 2 times p of 2 plus 3 times p of 3 plus 4 times p of 4 plus 5 times p of 5. And mathematically, we write it this way. We say that, hey, mu is equal to the sum sigma, capital sigma, represent the addition sum. So sigma sum of x times p of x, x times p of x. Write it in expanded form this way, write it in compact form this way. Okay, guys, take your time, calculate the mean for me. So as you saw, 1 times 16%, plus 2 times 22%, plus 3 times 28%, plus 4 times 20%, plus 5 times 15% is 2.94. This is the average score. It's close to 3, so I say, hey, the average score for these employees is 3. Okay, this is the center that we found. This is our center. Now, what about the variability? So I'm going to write down the center here on top. Mean for expected value for the center is 2.94. Keep that guy. Keep that guy. Let me erase the rest of the board to find variability. The variability has a little bit of more calculations. To find variability, especially standard deviation, so standard deviation or sigma is equal to, well, you need a square root. Okay, what are you going to do? You're going to take each x, multiply that. Let's see. Take each x, use your mean to find the deviation of each x from the mean. Then square that and multiply by p of x. Okay, let's see what do we have. X, let's write down the sum as well inside your radical. The sum of x minus the mean to the second times p of x. Then add them all together. So what do I mean by that? It means that sigma is equal to square root of. Okay, have more calculations here. The very first x is 1. 1 minus mean, which is 2.94 to the second times p of 1 plus the second x is 2 minus the mean 2.94 to the second times p of x, p of 2 plus the next x is 3, so 3 minus the mean, 3 minus 2.94 to the second times p of 3 plus, we have 2 more variables, 4 minus the mean, which is 2.94 to the second times p of 4 plus, and finally, the last variable is 5. 5 minus the mean, 5 minus 2.94 to the second times p of 5. All of these are inside your radical. It gives you the sigma. So sigma is equal to square root of what? What is the number inside your radical? So everybody, what's the probability of 1? The probability of 1 is 16%. You can write it as 0.16. So you can just replace these. Then the probability of 2 is 22%, 0.22. The probability of 3 is 28%, 0.28. The probability of 4 is 20%, 0.20. And the probability of 5 is just 14%, so 0.14. So guys, you need to raise the number to the second power, multiply it by 16% plus raise this number to the second power, multiply by 22%, and you continue this process. Remember that raising to the power and multiplications come first, then you're going to do the addition. If you do that, the variance or the number inside the radical becomes, let's see, let's have the exact value, 1.6164, 1.6164. As you remember, this number is your sigma squared, or this is your variance, which has the unit squared We are not interested in the variance that much because it has a unit square. And if you take the square root, you're going to have about 1.3. So you're going to say that, hey, my center is around 3 and my variability is 1.3 in the square. This is my variability. This is our variability. Very well. So when we're talking about a discrete random variable, we have a very important experiment related to this discrete random variable. We call it a binomial experiment. Very good. Binomial experiment. There we go. So when you're talking about the binomial experiment, you're actually talking about an experiment which is a probability experiment that follows the following conditions. A binomial experiment is a probability experiment that follows the following condition. Very well. The very first one is that the experiment has fixed numbers of tries. The experiment has a fixed number of tries, and they are independent from each other. Independent from each other. The key word that we are seeing is with replacement. With replacement. And similar to that. They must be independent from each other. Very good. Well, the second condition is there are only two possible outcomes. There are only two possible outcomes, either success or failure. Success or failure. The probability of success is the same for each trial. Of success is the same in each trial. And finally, random variable x counts the number of successes in these trials. The random variable x counts the number of successes. Okay, so just be careful here. If you have fixed numbers of tries, you usually denote the fixed number of tries by n. You have n numbers of tries. the probability of success, the probability of failure. They are denoted by P and Q. Q is 1 minus P. So you have success or you have failure. 2 possible outcomes, no more than that. The probability of success is denoted by P. The probability of failure is Q, or 1 minus P. Random variable X counts the number of successes. Okay, so it means that X can be 0, no success at all. That makes sense. Or just 1 success in the trial, or 2 successes in the trial, or 3, or 4, we can count them, or 5, or it stops at N. So when you're talking about X in general, in a binomial experiment, they say, hey, what is random variable X? You're going to say that, hey, X counts the number of successes, and then it starts at 0, no success at all. 1 success, 2 successes, 3 successes, and up to N included. So suppose you have, for example, 9 surgeries. Okay, the patients are independent from each other. The surgery on patients are independent from each other. Okay, and suppose you have, for example, 10 surgeries. N becomes 10, and then depending on previous experiments, you're going to get information about the probability of success in each surgery. Then the variable X, random variable X, discrete random variable X, counts the number of successful surgeries. 0 success, it means that surgery wasn't successful on any of the patients, unfortunately. 1, it means that you had just 1 successful surgery. 2 successful surgeries. 3 successful surgeries, 4 successful surgeries, or 10, it means that all of those surgeries were successful.